This is TechSNAP, episode 369. Welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on May 22nd, 2018. It's brought to you by our three great sponsors, DigitalOcean, TIng, and ixSystems. I'll tell you more as this show goes on. My name is Chris, and joining me every single week is my co-host, the admin, the engineer, and the presenter, Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris.
Hello, sir. We have a traditional security-focused episode of the TechSNAP program for everyone today, from new variants of Spectre to getting root access on a Linux box over the network. But let's start with what researchers have found in Electron, a flaw in the software framework that's been in use for the past half-decade for building tons of popular desktop applications.
Yeah, absolutely. It really is popular. I'm probably running, 6 Electron apps right now. And it's popular because it allows developers to easily port web-based apps, just written in standard JavaScript, HTML, CSS, and run it on the desktop with the minimal amount of work. And obviously, as we're all pretty lazy, that's great. It works by wrapping a custom API around the Node.js server-side JavaScript engine. Now, when building Electron-based apps, developers have the options of using a more limited environment by using mostly just the Electron API, or tapping into the more full-featured Node API. Because the Node project is a more mature project, Node's APIs and built-in modules provide a deeper integration with the underlying operating system and allow the developer and the application access to a ton of additional operating system features. The Electron team was aware of this problem and created a mechanism that prevents attacks on Electron-based apps that tap into these APIs to try to harm the underlying OS. For apps that just want to run HTML and JavaScript code on the desktop, simple apps where you don't want to have security risks, there's a flag, Node integration. Once you set it to false, which is turned on by default, access to the Node APIs and modules is disabled. Unfortunately, as is often the case, the real story is a little more complicated. Electron-based apps work with a web preferences config file. In that file, there's a web view tag, which is usually set to false. And when it is set to false, Node integration is also set to false. If developers have not declared the WebView tag at all, then the app also considers Node integration set to false. But this is where the problem lies. Basically, there's a mechanism that allows malicious actors to turn the Node integration option to true and then grant themselves access to the more powerful Node API. If developers of an Electron-based app have not specifically declared the WebView tag, inside the web preferences config file, an attacker can use any of the mundane cross-site scripting attacks that we've talked about here on TechSNAP inside an Electron app to create a new WebView component window where they control the settings, and then they have full control to change the WebView tag and therefore change the Node integration tag.
Holy smokes, that's a huge range of potential vulnerabilities.
Yeah, exactly. Now, remind you, Electron-based apps are packaged HTML and JavaScript code, so finding that cross-site scripting attack probably isn't as hard as it sounds, as we see that happens all the time on the web. The researcher at TrustWave, Brendan Scarvell, published a proof-of-concept attack that can exploit any cross-site scripting flaw. So once you found those, and then once you have one of those, use his proof-of-concept, extend your access to the underlying OS, and get full access to the Node API. And it affects basically any vulnerable version of Electron, which is something like less than 1.7.13 or 1.8.4 or 2 beta 3. It's not quite clear.
Oh, really? So it could be a decent range, which means there's probably plenty of Electron apps in production still that have this vulnerability.
Yes. So the good part here is that the security researcher privately reported the bug, and the Electron team has released fixes way back in mid-March. But what's not clear is how many of the popular Electron-based apps that you and I are using have actually updated the framework behind it and shipped those fixes to us.
Yeah, just because the app's been updated doesn't mean the framework they're using has been updated. And what strikes me about this, it seems like an impossible problem to solve because Electron is based on so many other underlying technologies that you end up building these preventative measures into it to try to almost mitigate what it's based on. Do you follow what I'm saying? Like Electron itself is almost inherently too complicated to prevent these kind of issues, and mitigations are only going to go so far.
I see it as a mirror of the problem that browsers are having, right? You want this full-featured web. We expect a lot out of the web these days, and without all those capabilities, it's hard to reach that level of functionality. But at the same time, those capabilities add extra risk, and the browsers have done a ton of work trying to better their sandbox. Obviously, Electron does too. It needs to do that as well.
Yeah, that's a great point.
Yeah, there's definitely room to improve, but I am pleased to see it seems like everyone involved here has done the right thing. Good notice without identifying it to the public was given to the project, and Electron on their side got things patched pretty quickly. Also, it's not like they're the only software project that has these sorts of problems. A lot of frameworks are more complicated these days, and the problem of bundled vendor dependencies is a wide one.
The Universal Plug-and-Play networking protocol has always been a friend to security researchers because they could use it to abuse networks. Well, this week, they have another reason to love it. The InfoSec community has discovered a way to assist denial-of-service attacks using Universal Plug-and-Play.
Yeah, that's right. And if you're not already familiar with uPnP, boy, I envy you. Basically, it's a convenient way created by a consortium to let gadgets, to let devices on your network find each other, and the key part here, if necessary, modify your router to allow the device access from outside your network. This is used a lot if, let's say, you're running a Plex server or you've got an Xbox on your network, and that will dynamically forward ports on your router to the device so that you can, get through NAT, that sort of thing. Obviously, there's a big risk there.
Super convenient, but not surprising that there's a big risk with something that automatically adjusts your networking equipment. We've covered a ton of stories in the past on TechSNAP about Universal Plug-and-Play and using it to abuse your network.
Yeah, exactly. And it's commonly a feature that most people don't even know. It's enabled on the router firmware. You don't have to set up anything. Of course, that's a nice experience for the end user, but not so secure. And this is just another example. In this proof of concept, distributed denial of service attack, Imperva researchers have devised a way to exploit uPnP to bypass its mitigations and carrying out just huge amplification attacks. Now, this proof of concept in particular stems from their analysis of reflection-based DDoS attacks back in 2017 that exploited varying protocols to magnify their impact. For example, the network time protocol amplification-based DDoS attacks, which represented almost a third of assaults that they've been tracking. There have also been other ones that we've talked about here. Reflection-based amplification using the domain name system has been super popular of late, as well as the Simple Service Discovery Protocol, or SSDP, which also are well represented in their dataset. Now, to big players in these spaces, mitigating against these attacks has become kind of routine. The researchers point out that blocking all packets with source port 53 is considered a tried and true method for mitigating DNS amplification attacks. That's why they became intrigued by an unconventional SSDP amplification attack that they spotted in April. We noticed that a certain percentage of SSDP payloads, sometimes as much as 12%, were arriving from an unexpected source port and not UDP 1900. SSDP is a protocol that uPnP devices use to share data using UDP. Now, the researchers tried to reproduce the attack, and they were able to devise a novel uPnP integrated attack method that could be used to obfuscate source port information for any type of amplification payload, including SSDP, DNS, or NTP attacks.
Oh, that's nice.
Right? How convenient. A simplified description of this proof of concept entails using the Shodan search engine to find exploitable uPnP gateway devices and a uPnP associated file called root description or rootdesk.xml for root description. Now, cataloged in this XML file are basically all of the available uPnP devices and services available on that network. Once an attacker has identified that file, they can use it to determine actions that the device will accept remotely. In their proof of concept, one of these actions is add port mapping, a command that can be used to configure port forwarding rules. So using this scheme within the file, you basically send a SOAP request, which can be specially crafted to create a forwarding rule that reroutes all UDP packets sent to port 1337 to an external DNS server.
Holy smoke. So there's a whole range of gateway devices with Universal Plug-and-Play turned on where you can get this root description.xml file, which is like the map of all of the devices that have Universal Plug-and-Play support. This is a thing that exists?
Yes, it is.
Good old Shodan. Of course they have an index of it.
Yeah, and then you're just able to add these rules, and since routers, they're routers, they have a lot of this rewriting functionality built right into them, and so suddenly you've turned this person's network from innocent to suddenly rewriting a whole bunch of traffic that they sent legitimately, and then attacking and then amplifying from various DNS or NTP servers on the internet.
So what that really means when you're thinking of mitigations is that the source, IP, and port information is just no longer a reliable source of filtering. Like, you can't filter based on that information because it could be completely spoofed.
Yeah, exactly. So there's just less things to key on, and it makes it more difficult to determine legitimate traffic from attack traffic.
I think you briefly mentioned it in there, but back in March, GitHub suffered that massive DDoS attack that measured 1.3 terabits of sustained traffic for 8 minutes. That was an attack where the attackers used a memcache de-amplification technique, and at the time, we said we're going to see a lot more of these. And the reason is pretty straightforward. It's economical. Not only is it great to hide your source and it's confusing to filter for the admins, but it's extremely economical because you're not using your own resources or your own bandwidth. So you just have all of these reasons for this type of attack to just kind of explode. And universal plug and play is going to make this even easier. I hate to say it because I know it's very convenient, especially on a home network. But the advice of the day here might be you really have to disable universal plug and play. What do you think, Wes?
No, I agree. There really do need to be more secure controls or more thought put into this. Now, obviously, it's super convenient, and there's some part of me is sympathetic to, just the layman who doesn't really understand ports, who doesn't understand anything about firewalls or NAT, and just wants to, play their video games with their friends. That's tricky. But maybe with some more standardization, maybe with some, some standard UI, standard API, standard tooling integrated into operating systems, but with security in mind, we can mitigate this. If you're listening to this program, that's probably not you. So just turn it off. Forward the ports yourself. It's not that hard.
do.co/snap. Build better applications faster with industry-leading performance and predictable costs at DigitalOcean. That's do.co/snap. When you go there with a new account and sign up, you'll get a $100 credit. Now, you can kick the tires for quite a while with $100. It'll last for 60 days, and my favorite rig is 3 cents an hour, to give you an idea of how far that's going to get you. They have incredibly fast infrastructure. Every system uses SSDs. 40 gigabit connections coming into the hypervisor. Very carefully chosen data centers all over the world. And you can build a lot in 60 days. You can get systems spun up in less than 55 seconds. They have all kinds of droplet types, from standard CPU systems to CPU optimized systems with big, fast CPUs, or my new favorite, the systems where you can mix and match your resources. The flexible droplet, $15 a month. You pick and choose what's best for your system. They have an interface that's very straightforward. The dashboard itself is great, and they have an API that's clear and well documented, and tons of good applications are built around. Deploy an entire stack of applications or just the base rig. You can get started in less than a minute. Just go to do.co/snap. Well, if you're a user of Signal's desktop application, you may have noticed a couple of updates recently. That's because there's been some severe code injection vulnerabilities.
Yeah, that's right. This time around, they've discovered an attack that allows attackers to inject malicious code into a Signal desktop app just by sending you a message. No user interaction required. Now, in the previous exploit, there was a flaw in the function that handles links shared in a chat, whereas this vulnerability exploits a flaw in the function that handles validation of quoted messages. So basically, to exploit this newly patched bug on a vulnerable version of Signal Desktop, all an attacker would need to do is send a malicious HTML and JavaScript payload as a message to the victim, and then quote and then reply to that same message with any random text. It doesn't matter. All you need to do is trigger that quote function. If the victim receives the quoted message containing the malicious payload on a vulnerable desktop client, it will automatically execute the payload without requiring any user interaction.
Oh, okay. So they can send a message and then reply to their own message and quote it, and that's it. That's all. All that has to happen beyond the user just reading it.
You just spam them with 2 messages in a specific way. And once you've opened it and looked at it in your client, boom, the JavaScript is executed.
Wes, this happens to me on a daily basis.
It sure does, yeah. So until now, most of the proof of concept payloads used to demonstrate this were limited to embedding an HTML iframe or an image or video or audio tag. But this time around, there's a new proof of concept that could allow remote attackers to successfully steal all Signal conversations in plain text just by sending them a message. Basically, they have some specially crafted JavaScript that gets executed with this vulnerability, and then it scrapes through the Signal desktop app and finds all your messages, pulls the text, and sends them back to the attacker.
And it gets around the Signal encryption, which is maybe the most damning thing about this flaw.
Right, yeah. I mean, Signal's very popular with activists or anyone who takes security and privacy seriously, just because they've spent a lot of time engineering and testing and getting audited their encryption standards. But, of course, once you're running the client on the desktop, all those messages are rendered in plain text. It does get a little worse as well. The researchers also thought that an attacker could include files from a remote Samba share using an HTML iframe. They write, in the Windows system, the CSP fails to prevent remote inclusion of resources via the SMB protocol. In this case, remote execution of JavaScript can be achieved by referencing the script in a Samba share as the source of an iframe tag, and then just replying to it.
How is it possible that an iframe inside the Signal application can get access to Samba shares on the network?
It looks like the underlying operating system is basically handling that for them. It tries to, it can resolve the SMB link, and then it just loads the file, loads it into the iframe. Interestingly, we've seen the same attack technique used recently in a vulnerability in Microsoft Outlook disclosed just last month. So clearly it's popular.
But there is some good news, though.
Yes, there is. The researchers responsibly reported the vulnerability to Signal, and the Signal developers have patched the vulnerability with the release of Signal Desktop 1.11.0, available for Windows, Mac, and Linux, so go get your patches.
When the researchers made their information public, I tried to sort of dig into how Signal, the team, responded to this. And I was actually so impressed that I went and signed up for a Signal account, because I was just having a conversation with Angela in Tech Talk today. The real issue is you can trust the math, but it always comes down to the implementation of how you use that math. And that is more and more complicated. And you can trust the fundamentals, but you can still have simple implementation problems. Maybe you don't have the right kind of client-side protection, so you allow an SMB share to get accessed. These kinds of things are common. We just talked about issues with Electron applications as well. So you're going to have issues with these really complicated desktop applications and mobile applications. But if the protocol is sound and the team responds to these security issues in a responsible and fast way, that's sort of the best you can hope for right now. I know that sounds a little bleak, but I think it's the reality. Technology is extremely complicated, software is hard, and it's really about the follow-up. And that's where Signal impressed me this week.
Yeah, absolutely. And at the end of the day, you can prove the math correct, but there's going to be a team running these services and responsible for the updates. So you need some levels of trust, especially with important encrypted applications like Signal.
Red Hat's recently patched a pretty significant vulnerability that affects the DHCP client packages that shipped with Red Hat Enterprise Linux 6 and 7. A successful exploit could even give an attacker root access and full control over certain enterprise endpoints.
According to an alert issued Wednesday from the U.S. Computer Emergency Response Team, the critically rated flaw, first reported by a Google researcher by the name of Felix Wilhelm, could allow attackers to use maliciously crafted DHCP server responses to execute arbitrary commands on target systems as the root user over the local network, if those systems use Network Manager and are configured to use DHCP. The attack takes advantage of the way the DHCP protocol is used to dynamically assign IP addresses to computers, i.e. the fact that the endpoint clients essentially broadcast out a query over the local network to obtain an address from the DHCP server. When a computer connects to the network, it basically says, hey, I need to know my IP address, and then it expects to receive a response from the DHCP server containing the IP address it's to use on that network. That answer could contain a malicious reply from the server so that the system gets back not just the IP address, but also a malicious payload. This vulnerability could allow that payload to execute as the root user so that the attacker could have essentially full control over the targeted system. Now, of course, the DHCP responses often contain a whole number of various DHCP options, and in this case, it's a vulnerability in a script that's run every time Network Manager receives a DHCP response. There's a vulnerability in that shell script, which then allows certain payloads to execute as shell script as root.
So this is why it's specific to Red Hat systems, is because it's in their shell script implementation.
Yeah, exactly. You can find it under etc Network Manager dispatcher.d11-dh client on RHEL 7, at least. There's a couple different names depending on if you're running RHEL 7 or 6 or Fedora. You can go check the show notes to find all of Red Hat's details about that. Christopher Robinson, manager at Red Hat's product security assurance team, said that a possible scenario would be that an attacker could open a reverse remote terminal, allowing them to have pretty much full control of the machine they're attacking.
I was trying to speculate how to do this remotely, how to take advantage of this, because, being a DHCP server on the LAN's a pretty hard thing to pull off, but they came up with it. It's that reverse terminal.
Yeah, it seems like there's many possible attack vectors. And of course, as we like to talk about, island hopping, chaining, these are all viable attacks. Once you've got any access to the network, you can either try to take over a legitimate DHCP server or set up your own spoof DHCP server on the network and start sending your own replies to DHCP requests. There's also the issue that DHCP is used all over the place and users are way more commonly attaching themselves to different networks. You go into Starbucks, you're attaching to their Wi-Fi. Someone else could be running a DHCP server on that network, and if your computer happens to receive their malicious response before the legitimate response, game over.
I actually prefer to run my servers on DHCP too. I know that probably sounds weird to a lot of the folks in the audience, but even now today at Jupiter Broadcasting, when we set up gear, I have everything set to DHCP, and then I statically assign the addresses in the DHCP server to certain hardware. And then I always get the same address on those machines, and the DNS points to the right machine and all of that. But I have found that that's particularly useful in a virtual environment, but it's also just very useful in an environment where you're reloading equipment, and sometimes you have different people working on the gear. The more I can sort of endow the machine with via DHCP, the better, because that's less variability in the configuration. And I have been in situations where this bit me because another admin on the network, this is years ago at a different job, set up a DHCP server on accident. And I think it was attached to a wireless system that he was working on. And the way DHCP works is it's just kind of whoever responds the fastest. And in this particular case, a few machines, for whatever reason, were getting responses faster from his DHCP server. And that did mess stuff up. So I have been in situations where a rogue DHCP server comes online and then you have to track that sucker down.
Right. I mean, it can really cause havoc on the network. I also take your point well that, in many cases, if you don't already have some sort of larger configuration management system where you can manually assign IPs or keep track of a large list of statically assigned IPs, DHCP can often be just enough control, right? You can change IPs that are assigned, you can match on MAC addresses or host names or other features, and you can push a whole bunch of options from, additional routes to different gateways, so it can be really convenient. You can find patches for Red Hat Enterprise Linux 6 and 7 in them show notes, and stay tuned, the Fedora and CentOS project will soon have their own patches released as well.
TechSNAP.systems/369. ixsystems.com/TechSNAP. Go there to land at the ixsystems page to learn more about them and support the show. IX is a leader in implementing open source software technology on hardware that is incredibly well priced, great performance, and backed by an incredible company. That's ixSystems. And they just recently went to the Boise Technology Show, and they have a recap up on their blog. Now, every year, Fisher Technology, which is an Idaho TV channel, they also have a presence here in Seattle, no relation to me, but they hold a one-day technology show, and ixSystems went there, and they were the platinum sponsor. Platinum. Fancy. Because you know what the TV industry needs these days? More and more disk. And that's why they went to ixSystems. They're the people behind TrueNAS, which is the leading NAS system that has great ZFS implementation, full support for VMware systems, and it's it's a product that you can go check it out, but I also think you should consider maybe looking at FreeNAS, which is another product that we talk a lot that ixSystems is also involved with. Now, FreeNAS is great for small businesses or for your home system. So there's two different product categories they have just for storage, but that's not all IX does. They also build systems for compute. If you have a big cloud deployment that you want to bring on premises, ixSystems has solutions ready to go for education, for finance. They have a wide category of systems. And if you really just need anything that runs on open source technology, ixSystems probably has a solution for you. I've been a customer for a long time. ixsystems.com/TechSNAP. Go there to learn more and also download the white paper that might just help grease the wheels up the chain in your company. ixsystems.com/TechSNAP. This week, we learned of a fourth variant in the data leaking meltdown Spectre type security flaws called Speculative Store Bypass. What exactly are we dealing with here, Mr. Wes?
Well, of course, as with anything dealing with CPUs, it gets a little complicated. Now, Chris, you're familiar with dynamic random access memory, more commonly just called RAM, right?
Loves me some RAM.
Yeah, right. And so, of course, we have the problem that RAM, it's kind of slow. It's gotten faster, but basically it's slow, and it's too slow. If we just used RAM, it would really hold up modern processors. So
yeah, it's too slow for the CPUs. They are sitting there waiting for the data to get to the RAM and back, and they need to make decisions faster than that.
Yeah, exactly. And so we now have a lot of caches, fast caches, located right on the CPUs. These often contain copies of reads and writes, or what microprocessor designers call loads and stores. And then whenever external memory is updated with a new value, you first write to the cache, basically into the store buffer, as it's called, and then that buffer is eventually checked and written back to the external slow RAM. This is something we already see. You can really see analogs, right, with writing to slow disks. In that case, RAM is the fast party, so you write to RAM, and then the OS flushes from RAM to disk in the backend. This is the same thing, but one level lower. And the basic idea is, yeah, the processor can have a fast buffer, it can keep going, and then let things flush out as needed. And of course, that buffering greatly increases performance because the microprocessor does not have to wait for the buffers to be written back to slow memory. But it introduces a complication. Data read from memory might have been updated by an outstanding write that's in the buffer, but hasn't actually made it out to external memory yet. So every time the processor performs a load, it must check the store buffer to see if that address has been part of a recent update. In fact, things are even more complicated by the fact that modern microprocessors allow unaligned access, meaning that addresses might not exactly match, but could slightly overlap. So there's a bunch of logic required to search the store buffer. It's complex and slow. This process is sometimes known as memory disambiguation, but kind of that term varies by vendor. In all of this, store buffers are really sophisticated, and they utilize really fast memories, content addressable memory most times, but searching them for all possible overlapping memory addresses takes a lot of time. So rather than wait for serial searching of the store buffer, many modern processors implement a performance optimization known as Speculative Store Buffer Bypass. That assumes no such update is present in the store buffer and then speculatively executes the program instructions while performing that store buffer search in parallel. So let's say that again. Basically, we're reading from memory, but we don't know if that memory might have been updated by something in the store buffer. So instead of actually waiting for the search to see if there's any change to that address, we just speculatively execute whatever code was going to need what we were about to read. And then in the common case that no matching store exists in the buffer, great. Whatever we speculatively executed, just keep that result. If, however, we find a conflict, we see that, oh no, that memory address was updated, then you update the memory address and then re-execute that code. This process greatly improves performance because conflicting updates are unlikely, right? We don't often see that, so most of the time there is no conflict and the speculative executed program, you just get to keep whatever it executed. Normal program code, of course, performs loads and stores to and from memory. These typically take the form of machine-level instructions with a base pointer and an offset. But while loads and stores are common, programming tools such as compilers and language runtimes are already optimized to prevent reloading of frequently used data, trying to improve performance at that level. As a consequence, a great amount of effort already happens to be spent reducing just the kind of circumstances required to have conflicting load and store in processor store buffers. Also, many processors are designed to handle loads and stores using the same base pointer differently from those that have a different base pointer. In these designs, the circumstances required for a speculative store buffer attack are even more complicated. Meltdown and Spectre recently demonstrated that aggressive speculative execution, such as store buffer bypassing, really effectively improves performance, but only as long as it behaves as an unobservable black box, right? So if we can't tell that these optimizations are happening, then it's great. It's faster, it's better. Unfortunately, in reality, the speculation apparatus has observable side effects on shared resources, such as the high-performance cache memories contained within microprocessors. Loads and stores will cause data to be loaded into caches, or may be evicted from them. Careful timing of subsequent loads and stores can then be used to determine whether those values were previously cached. As a result, it's possible to infer what data has been loaded speculatively. This process is known as a side channel analysis because secrets are not leaked directly, but instead inferred by measurement. Now, of course, we've talked about this a bunch on previous TechSNAP programs. In particular, check out TechSNAP 351. In the case of variant 4 here, when side channel analysis is applied to store buffer speculation, it's possible to leak earlier values of certain memory locations. Unlike in previous attacks, though, speculative store buffer bypass usually allows only reading of memory locations from within the same privilege level. So it would allow a kernel to attack itself, or an application to read memory to which it already has legitimate access, but not go from user space to kernel space. So in that sense, it's a little better than some of the other variants.
And this impacts more than just Intel CPUs. It's AMD, ARM CPUs, as well as IBM's Power 8, 9, and System Z CPUs. But at least according to Intel, mitigations that have already been released to the public for Variant 1, which is the hardest vulnerability to tackle here, should make the attacks leveraging Variant 4 much more difficult. In other words, web browsers and similar programs with just-in-time executions of scripts and other languages that have been patched to protect from Variant 1 attacks, those patches should also derail Variant 4 exploits.
Yeah, we've already become somewhat aware of the risk that speculative execution can have, so thankfully there's a lot of already deployed remedies that should protect us a little bit. But that said, mitigating speculative store buffer bypass attacks completely, it's still a complicated topic. We could simply globally disable every speculative performance feature, but that would rapidly remove many decades worth of performance gains across the industry. And doing so wouldn't necessarily make us any safer because in most cases, store buffer speculation is safe. That's because applications that rely on process level separations aren't really impacted by this vulnerability. So a big hammer approach of just disabling this outright would really kind of unfairly penalize a whole bunch of applications just to protect the few that could be exploited. Now, the Linux kernel is taking a somewhat interesting approach to this. By default, updated kernels will provide mitigations for this vulnerability, but they'll leave speculative store buffer bypass enabled globally, and instead will provide a new standard API intended for sandboxes and other managed code environments that could be at risk from this exploit. So applications that are providing sandbox environments or are especially vulnerable to this have access to a new PRCTL interface through which they can determine whether the process that they're running on is vulnerable, and then they can easily disable store buffer bypass speculation on a per process level in just a few lines of code. When such a per process level mitigation is applied at runtime, it will apply to all further processes and threads created by an application while it continues to run. So the kernel here is helping out and saying, oh, you flipped a bit. You said, I'm unsafe. I'm running a sandbox. I'm running something that could be exploited by this. Keep me and my children safe. Thanks a lot, kernel.
This is a really interesting feature. Now, it does, like you say, require that developers modify their application to sort of take advantage of this secure computing framework. But the applications can essentially say, hey, put some limits on me because I am an important application that's doing something that's very data sensitive. So I'm going to request that you actually do limit my capabilities, but the rest of the system applications that can take advantage of speculative execution features are left with their original performance.
Yeah, and thankfully, a lot of those applications are things like browsers or common programming language runtimes or environments. So hopefully we'll see those used pretty widely. Now, of course, there's going to be a lot of, other small ramifications, niche programs that aren't going to see these updates in a timely manner. But it is worth noting that really so far as of today, we haven't seen any malware really in the wild that's been actively attacking really any of the Spectre and Meltdown holes in today's chips, let alone this latest variant. That may be because mitigations are widely installed, or just because these aren't necessarily always the easiest exploits to attack. That said, as we've predicted, and as many have said, this is, especially Spectre, this is a class of vulnerability, a class of issue with modern processor design, so I imagine, even with V4, there's going to be a couple more versions to come before this story ends.
And more firmware updates. Intel and others will issue new microcode updates and software tweaks to fully counter, as best they can, this new variant. TechSNAP.ting.com. Smarter than unlimited. If you use less, you pay less, especially if you go to our URL, TechSNAP.ting.com, where they'll take $25 off a device, or if you bring a Ting compatible device, they'll give you $25 in service credit. Ting's average bill per phone is $23 a month. It's $6 for your line, and then just your usage on top of that. And that usually works out to be about $23 per month. There's no contracts. There's no agreements. They have nationwide coverage, CDMA and GSM. And you just pay for what you use. You're in control. You can always see your usage. You can set limits. You can turn devices on and off. It's all available at the Ting control panel. Start by going to TechSNAP.ting.com and then take a look at some of their devices. If you go to our URL, they'll take some money off a device, like $25, and you could potentially walk out of there with a pretty great device if you want something new. I might turn your attention to the multi-network Motorola Moto G5S Plus. The G5S Plus is a pretty nice device. It's got CDMA and GSM support, so you can choose whichever network is best for you in your area. It supports turbocharging. In 15 minutes, you get up to 6 hours of power, and you can go up to 128 gigabytes with an SD card in there. And it's got a pretty nice screen, a 401 ppi screen with Gorilla Glass 3. It's 5.5 inches on that sucker. And it's an all-metal design with Android 7.1 and an Android 8.0 update coming soon. And Motorola is actually pretty good about that kind of stuff. It's a really nice phone. And if you go to TechSNAP.ting.com, you can get it for $254. No contract, no agreements, no fees like that. You could just get a phone. You just use it when you use it and pay for it when you use it. It's really simple. For $254, you can have a great phone. TechSNAP.ting.com.
Thanks for going to TechSNAP.system/contact to send us your feedback or your war stories.
Yeah, like Dave did. He sent a couple in. This first one goes, I've worked for companies making wholesale lockbox systems since 1992. Basically, we build and integrate systems which process wholesale check payments between companies. Last year, our system processed around 1.8 trillion in transactions, almost all of which ran on FreeBSD. He just mentions that.
Just throwing it in there, yeah.
Years ago, before I was an employee, a company I worked for built a system for a bank in Dallas using a data general machine. This machine kept resetting itself randomly, and the problem couldn't really be identified. Over the course of around half a year, everything was analyzed until finally, our company had 3 to 4 technicians on site using scopes and meters on every part of this machine, which they thought might be problematic, but yet the problem still persisted. Finally, partially out of frustration or perhaps desperation, they built a physical cage around this machine to prevent any access, intentional or incidental. Soon after they were called in because the machine was down again. It hadn't reset, it was just powered off. A bit of investigation revealed that someone had been flipping the 220-volt AC power off and then on to reset this machine, causing a long reboot process, which allowed employees near the end of a shift to leave a few hours early. Since access was denied by the cage, the person had flipped the 440-volt wall panel switch instead, not realizing that it required a key to flip it back on. A quick check of their records revealed that the problem hadn't happened when a certain floor supervisor was on vacation, so they narrowed the problem down to him, and I believe he was let go. Just one of the many headshakers I've heard from folks who were there at the time.
Yeah, I think that's a good case in point why you want to be friends with IT so that they're on your side.
Also, it shows you how companies can have these massive disconnects. So IT is going through weeks, perhaps months, bringing people in with meters, building cages, obvious angst is happening in the IT department, and yet this floor manager is completely unaware that they're even trying to narrow it down, because if they were, they wouldn't have gotten caught. They would have stopped. And so the two hands in this company just had no idea what they were doing, which is also a funny subtext there. But Dave has another one. Do you want to take it?
Oh, yeah. Howdy. Another story sort of related to the first. Years ago, a server on site would reboot itself on Friday afternoons a few hours before the end of the shift. This would set off a time-consuming disk space check. Oh boy, I know that one. And people would be sent home early. Surreptitious video was set up to watch whatever was going on and caught a lady going into a drawer of her desk, taking out a huge screwdriver, walking over to the server, and rattling the screwdriver around inside the power supply area until something shorted and reset the server. As the story goes, she wasn't fired, for whatever reason. And of course, these days, she'd have ZFS, and it's a mission of FSIC, or the equivalent, so it wouldn't be a huge deal. I wouldn't have tried such a stunt myself for fear of being electrocuted.
That's the first thing I thought is, how are you not getting electrocuted, and how desperate are you to get out of there that you would do that?
I mean, a sunny Friday afternoon, personal safety be damned.
I'm noticing the theme there too. Like, people just want to go. Egon writes into the show, and he writes usually to Coder Radio. So apparently Egon's cheating on Coder Radio.
Oh, hey, we're happy to have you, Egon.
We certainly are. He says, but my trade is being a system administrator by day, even though I typically listen to Coder Radio. And it's a company that delivers and runs complex systems for international customers. A few years ago, I took mislabeling to the next level and into the 21st century. The ESXi infrastructure in our company is a shared one among other departments and teams. If you need something, you simply order it and build internally at the end of the month. But as it inevitably goes when something is virtualized, soon a long list of VMs and virtual networks were on the bill for each month. But one time, the single biggest amount of my bill belonged to a VM with a very cryptic name. I had no idea what this machine was good for. After asking my teammates if anyone had any ideas what this machine does, I decided to have this one deleted. A few weeks later, I heard a colleague tell the story that one of his machines he used to give customers access to our demo systems had just mysteriously disappeared. It turned out that the machine was badly labeled and assigned to the wrong cost center for years. I'm not 100% sure if I ever confessed there and then, but I have since campaigned for clear, consistent labeling of all virtual infrastructure. Love the show and the new format. Regards, Egon. A lesson that was learned, I think, Wes.
Absolutely. Thankfully, usually when you have virtualized infrastructure, you have some sort of metadata. You can have a tag or a name or a label. It gets even worse when you're bare metal and suddenly there's just an IP on the network or a MAC on the switch, and you just have to guess and hope, and maybe it's up, and who knows what it is or how long it's been there.
I had a labeling mishap in an Active Directory system where I actually thought I had a pretty good naming system until all of a sudden we wanted to merge with another company that had an Active Directory that sort of had conflicting stuff, and it just didn't work. Like, the whole structure didn't work out anymore. And I remember sitting there going, why did I do this? Why did I do this? So you can sometimes think that something works really well, and then your situation changes, and you just kind of have to roll with the punches. But as long as you learn from it like Egon did, I guess that's at least the silver lining. Egon, thanks for sending that in. Dave, thanks for sending yours in. He sent another one in that I read and snickered to myself, but I love these war stories and your questions. Keep them coming. TechSNAP.systems/contact.
That brings us to the end of today's program. You can find links to everything we've talked about at TechSNAP.systems/369.
And a public service announcement. One half of the TechSNAP program is going down to Texas. I am leaving this coming weekend. And so that may also impact a little bit when we record, or when it gets released, I should say. And both those things could be impacted by travel. But we do plan to keep the show going on the road. We're testing and experimenting with that right now in this very episode. And I'll be down in Texas for a few weeks. So if you're in the area, like coming and going, just check my rover, jupiterbroadcasting.com/rover. I got the tracker there. Maybe we can meet up at some point, talk some shop, tell me some more stories in person. That'd be pretty cool. But Wes, where can people get more of you in between episodes?
They can find me at Wes Payne or on that glorious Linux Unplugged program.
Hallelujah, Linux Unplugged. This is glorious. And you can find me, I'm at Chris LAS, and the whole network is at Jupiter Signal. Thanks so much for tuning in this week's episode of the TechSNAP program.
We'll see you next week.